A tarefa que me incumbe agora é bem mais difícil do que a anterior. Apresentar o próximo orador é uma tarefa para mim quase impossível. Mas vou tentar fazê-lo o melhor que sou capaz. Se me permitem, por deferência com ele, vou falar em inglês. Professor Sir John O'Reilly is currently a visiting professor at University College London and the chairman of the Science and Engineering Research Council in Singapore. He just came from Singapore. Sir John O'Reilly served as Director General of Knowledge and Innovation for the UK government. He was Vice-Chancellor of Cranfield University, Chief Executive of the Engineering and Physical Sciences Research Council, and hold also various academic appointments. Professor O'Reilly's personal research has been in the area of information and communication technology, with emphasis on communication networks. Sir John, as a fellow and former member of the Council of the Royal Academy of Engineering, International Fellow of the Academy II of Science and Techniques, and of the Academia das Ciências de Lisboa. Sir John knows well the Portuguese science and technological world. He supervised at least half a dozen Portuguese PhD students, now all holding teaching positions in Portuguese universities. He has been a member of FCT evaluation panels since 1996 and member of the advisory board of a few Portuguese R&D units. I know I have missed a large number of important points in Sir John's biography, but time urges, and we all want to hear him and not me. So, Sir John, you have the floor.
Bom dia. Thank you, Carlos, for that introduction. It's a pleasure to be here. I've taken as my title, Full Steam Ahead. Full Steam Ahead for Growth. But reference was made earlier to the recent referendum, so full steam ahead to I'm not sure what. But to explain what I mean by that, I should say that if there are any railway enthusiasts in the room, you're going to be disappointed. Because, of course, we're very familiar with STEM, science, technology, engineering, and mathematics, and the A is for the arts and humanities. And what I want to talk about is the seminal role of what is sometimes called the knowledge triangle of higher education, research, and innovation. And I put the word symbiosis because that, I think, is the relationship. Each requires the other, each supports one another, each enhances one another. And no nation, in my view, can say, let's be good at just one of these. To be good at any, you have to commit to make a real commitment to all three, I would say. So, let's start with higher education, by which I mean, in the first instance, universities, although it's broader than that, and look at some international rankings. There are three separate rankings here. The Jiangtou ranking out of China, the Times Higher Education ranking from the UK, and the QS ranking. And probably the most notable thing here is that they are not consistent. What is top in one is not top in another, and so on. These are the top 10 ranked universities. This data is, I think, from 2 or 3 years ago. But if I make a slight change to this, then something I think quite remarkable stands out. The colors represent the countries that those universities are located in. And there are only two colors. The United States dominates, of course, and the United Kingdom second. Quite remarkable. So although the individual institutions move around, this says something about the higher education, science, innovation culture in those countries. But it's not consistent, and it can change. These are more recent rankings from 2015, and you'll notice, again, the United States very strong, the UK very strong, but ETH Switzerland is now showing in here at number 9. But let me go just a little bit deeper, and you see Singapore come on to position 12 and 13. This is the QS ranking. If I use the different ranking, it will be different. Don't treat any individual ranking too seriously. But if several are giving you a common message, then give some credence to it, I would suggest. But the most noticeable thing here is I've put in also the positions of the two top Singapore universities in 2012, where they were ranked number 25 and number 47, and now ranked 12 and 13. Really quite remarkable. It says change is possible with commitment. Actually, change occurred here through commitment and also through a slight change in the way they calculated the rankings. But nonetheless, change, I assure you, is very significant from the investments and the commitment that they've shown. Now let's look at research. We commonly look at research in terms of expenditure, R&D commitment, the gross investment made, gross domestic expenditure relative to the GDP. And this shows it ranging from around 2003 to some of the more recent data around about now. For Japan at the top, for USA, for the European Union, that's EU28 in recent years, and for China, coming up very, very strongly. I've put into the right the UK's position, which you'll see is below the EU average, and the Portuguese position, which is slightly lower, but has been higher. It's changed over the years. I think both the UK and Portugal and many other countries, come the crisis of 2008, had to pull in, and it has had its impact. Now let me return briefly to universities, to this, sorry. Now let me look also at the performance in terms of research, and I would take the UK here as my example. Commonly quoted statistics, we have about 1% of the world's population. We fund about 3% of the world's scientific research, but produce something like 6% of the research publications and get something like 12% of the citations. And if you look at the top most highly cited publications, then something like 16% of those are UK publications. So this is an instance of a country that is underinvesting, but nonetheless is performing very well indeed. It's worth asking ourselves what might be doing that. And these two people, wise individuals, give us a hint. Goethe. Science and the arts belong to the whole world. The barriers of nationality vanish before them. Or Chekhov. There is no national science, just as there is no national multiplication table either. So science is international. Now, this, you will not read the detail, so let's go through some of the words, but it is a map of scientific interactions measured through collaborations in public, shown up through co-authorship of publications and so on. And the central region is where most of the action is, the big countries that we know. There are some colors in there that show how significant the research is, as well as how much of it there is. And it's quite networked. The central area, very strongly networked. The USA, Germany, the UK, Portugal is in there, France, and so on. And then there are the outliers, less connected internationally. Let's again take the UK example. Something like 48% of United Kingdom articles are internationally co-authored. A very high proportion of our science is actually undertaken in some sense collaboratively internationally. The UK internationally co-authored articles are 25% more cited than the UK average and 100% more than the world average. Size adjusted, the top 10 UK research partners are Germany, the United States, no great surprise, the Netherlands, France, Italy, Austria, Switzerland, Spain, Ireland, and Sweden. The United States, of course, and then Europe. Massively, massively interconnected in our science with our European partners. But the top-level message for me is international collaboration and high-quality science commonly go well together. And what about international students? Having talked about universities and research, where are they? This is in the world, and again, the data is from 3 or 4 years ago. But at that time, again, you will see the United Kingdom universities sitting up there strong. Some not so well known, but known for their research. So once again, we're seeing international collaboration through participation of students in the universities. So how do I feel about just over a week ago? Concerned. Yes, saddened too, I would have to say, Prime Minister. But for the university system in the UK, let's just get some indication of what it might mean. If you look at non-UK European Union students at UK universities, 6.4% of all full-time undergraduate and postgraduate students come from other parts of Europe, other parts of the European Union. And for some of the leading universities, an even higher proportion. My own institution now, UCL, 13%. Imperial College, 16% of the students, undergraduate and postgraduate, come from other European Union countries. And research funding, this is over the period 2007 to 13. The UK contributes in to the European Union research funding about 4.3 billion over that period in pounds, captures back something like 7 billion in pounds, which amounts to around 900 million per annum. The net gain, 340 million pounds per annum. Another research council. So that is what is clearly at risk. Collaboration between leading researchers in Europe, international researchers choosing to work in the UK. What did the minister say before the referendum? He said, in the short term, it's pretty obvious that there would be other claims on the public purse. So yes, I am concerned for the position of science. We stand from a position that is enviable, I would say, but seriously now at risk. But now let's move on to that third part of my triangle, innovation. The best antidote to stagnation is innovation, the creation of products and services that make life better, whether it's air conditioning, vaccines, or text messaging. Every country wants to foster a culture of innovation, but it's not easy to do. This was said by an American billionaire who'd made his own money, a venture capitalist, so he possibly knew what he was talking about. Now, in innovation, life gets more difficult to do comparisons. I've chosen one or two rankings to see again if we can take some messages from this. There's the Bloomberg ranking, GE produces a global innovation scorecard, and WIPO, the World International Property Organization, produces a global innovation index. At least, let's see if there are some messages from this. This is the Bloomberg ranking. You won't be able to read the words. I will pull out a few things for you. On the left is the overall ranking. Across the screen, you see the various components that are used to produce this. R&D investment, strength of manufacturing, high-tech, education, that is secondary level education, pre-university, research personnel, and patents. Those are things that are relevant in some sense to innovation. They simply average them to get their overall result. Top is South Korea on almost every individual measure and collectively massively invests in R&D. But elsewhere, things move around from one category to another. You'll see again, on R&D, Singapore is a relatively large investor compared with the UK and Portugal. It's much larger in manufacturing, but somewhat smaller in the high-tech industries where the UK is somewhat higher. Education is completely illegible because of the colors that I've chosen. But if we move to research personnel, here Portugal comes through quite strongly, as has already been mentioned. So those are some components in that ranking. What about GE? Well, on this listing on the left, GE, General Electric, a big company, does its own innovation scorecard. You'll see it has the United Kingdom and the United States at the bottom. Don't be too surprised, that's because they start with the letter U. This is in alphabetical order for the top 25%, okay? But the countries falling in the top 25% are, again, countries that we recognize, and strong in Europe, once again. Now another ranking. The World Intellectual Property Organization ought to know a thing or two about innovation. What do they come up with? This is their Global Innovation Index for 2015. Switzerland is number 1. Finland strong as a large investor. You'll see the UK in here is number 2. The US is at number 5. This one tends to emphasize the conditions for innovation, so maybe a leading indicator to some degree. But that was 2015. 2014, not so much change, although Ireland is in there. But if you look back at the UK, in 2011, it was 10th. So something has changed. It's worth asking ourselves, what might have produced that change? Well, here again, 3 other measures. At the top are the Global Innovation Index, where you see, in fact, in 2009-10, it was 14, and has regularly gone up there to number 3 and now to number 2. And that's the World Intellectual Property Organization calculates this together with 2 leading business schools, INSEAD and the Johnson School at Cornell. Below that is a World Economic Forum ranking, which looks at university, industry, collaboration, and interactions. And again, this data is for the UK. In 2007 and 2008, they ranked us as 12th. But again, consistent rises in subsequent years, and now sitting on that measure by them at number 2. And then a third indicator that is different again. The top right-hand side I know is illegible, but let me tell you what it's about. It looks not at patenting, but at the extent to which scientific publications from a country are cited in patents. So the extent to which the research is innovation ready, is producing stuff that can be made use of, perhaps in patents and so on. And in this again, the UK stands very high and has increased over recent years. Other countries, some others are increasing too. But an indication perhaps that the research is not only considered to be very significant in scientific terms through scientific citation in papers, but also is industry relevant to take up and so on. What changed in the UK around that time of 2007 and 2008? And I should caution, of course, correlation does not mean causality. But nonetheless, it is interesting when we observe it. In 2008, the Universities Funding Council took a small proportion of the funding that it sends to universities, recognizing their standing in research as part of their so-called block grant, and allocated this differently, not through their own measure of how good the research was, but took investment in industry, contracts placed with the universities by industry for research, as another proxy of it being worthwhile and good. So that's one thing that happened, was they decided to allocate some of the government funding to universities, informed, if you like, by industry's own judgments of where it might go. The research councils said, we want good research, but we also are interested in impact, that this can go out and make a difference on the economy and society. It caused quite a stir in the UK amongst the scientific community, but nonetheless, they said, please try and identify for us where you think your research will have an impact in those ways. And at the same time, the government had set up a technology strategy board as an arm's-length agency from government. Instead of doing the allocation directly from within government, it had an agent which was about funding research in industry on a collaborative basis between companies, with universities, and so on. Those 3 things occurred, and following that, we saw those changes. Not necessarily causation, but well worth thinking about and exploring, I would suggest. Culturally, I think very significant. In UK universities, you will find a lot more awareness and readiness of the value of those engagements. So international and others. Now, I made mention of STEM, science, technology, engineering, and mathematics. And of course, we divide this up in many ways, medicine, physics, mathematics, and so on. But real-world problems don't respect established barriers or traditional academic disciplines. I choose this example because someone I know, Stefan Hell, trained as a physicist. He works on super-resolution microscopy. He received the Nobel Prize in, I think, 2014 for chemistry. But he's a Max Planck director for an institute for biophysical chemistry. So not so much the traditional academic disciplines, both in terms of what he does and where it has its impact. And that brings me to Samuel Johnson, 1709 to 1784. I'm catching up on my background reading, you'll understand. Samuel Johnson said this: the chains of habit are too weak to be felt until they are too strong to be broken. It's a caution against carrying on as we always have and being unwilling to think differently, to look at different possibilities. And that applies, in my view, very much to research. We talk sometimes about pure science, pure research, applied research, and I'm very clear that very often in these circumstances, applied is seen as a pejorative adjective, as a negative, as a lesser good. Not my experience, not that of the Nobel Prize winner Sir George Porter, who said there are two kinds of research, applied and not yet applied. In fact, he was arguing for investment in, if you like, pure science because it was under threat. Today, I would reverse that argument. Let's make sure that we work right across this continuum. We've had him. Oh, no, it's Samuel Johnson again. Good research. What do we mean by good research? Well, he was a peer reviewer from time to time, and someone sent him their article, a book, I think, and asked for his comments. So if you like, in modern terms, peer review. And he wrote back to them saying, your manuscript is both good and original. But he then went on to say, but the part that is good is not original, and the part that is original is not good. However, I would say good is not one-dimensional, let's be clear, and in particular, that engagement with industry, with business, with the real world can be very powerful with very good research, particularly when you need to do things at industrial scale. And these are just some examples from organizations I've been with collaborations with Boeing, NASA, and so on, with Rolls-Royce, with the oil and gas industry, has produced outstandingly good research results while addressing significant challenges of industry. My personal experience is, if industry comes to me with a problem, it is invariably worth my giving it attention. Why do I say that? I know it's difficult, because they've already tried. And I find that very often, not only are we able to help them with their particular problem, but that by working on that, it illuminates my subject in different ways. I get different insights to the things that I would normally do by that engagement. So my theme is very much one of connectivity, join up, and interact, and there is benefit. And Alexander Graham Bell, inventor of the telephone, had a similar view. Great discoveries and improvements invariably involve the cooperation of many minds. It applies to reaching across from the physical sciences to the life sciences. Harold Varmus, a Nobel Prize winner who was head of the National Institutes of Health, went before Congress and argued for more money for the National Science Foundation, the physical sciences. Medical advances may seem like wizardry, but pull back the curtain and sitting at the lever is a physicist, a chemist, and an engineer. This is not an argument that the physical sciences are more important. It's an argument for connectivity and interaction and the fact that they are symbiotically related. Here's an example. I refer to this as a cyber biophysical system. Julie was in a car accident. She now cannot walk. Her life is in a wheelchair, lifted in and out of bed. But a colleague in electronic engineering at University College London, together with another colleague in medical physics and bioengineering, were working on electronic chips to implant into the body. To be able to sense when she wanted to move her legs, and to use that chip to trigger the muscles in her legs into movement. Julie, this is quite old now, Julie did not end up being able to walk, but she did start riding a tricycle, became independently mobile. And today, of course, we're seeing people, we are on the verge of that becoming something where we may be able to restore movement to people who've suffered that sort of damage. This could not happen with medical scientists concentrating narrowly on what they meant by medicine. It could not happen by electronic engineers concentrating narrowly on where they thought electronic engineering was centered. It came from the mutually beneficial interaction. And what a difference to make to an individual. So I don't like the pure and applied research. I prefer frontier research. And Professor Bergen, I know ERC, I think, was the champion of the term frontier research, recognizing it's about research at and beyond the frontiers of understanding. Intrinsically risky, I would say, progressing in new and exciting areas, characterized by the absence of disciplinary boundaries. The frontiers, we find them everywhere. Research is more connected than divided. But I want to speak briefly about the pace of change as well. This is an illustration, again, from something that I know from my own history. On the left, airships. Before we had aeroplanes, airships were going to be the answer, filled with hydrogen, of course. In the middle, someone called Harold Roxby Cox, and on the right, Neil Armstrong, the first person to walk on the moon. The link is Harold Roxby Cox. In his youth, he worked on airships before he got into aeroplanes, and indeed met one of the Wright brothers, one of the first men to take flight. And as Chancellor of Cranfield University later in his life, he awarded an honorary degree to Neil Armstrong, the first person to walk on the moon. So within the span of part of a lifetime, from first flight to first landing on the moon, for me, that speaks to pace in a very positive, very strong way. But it applies in other ways in science and research. This is currently a hot topic in solar cells and the like. Perovskite materials, they've been known for a long time, but the first paper suggesting that they might be useful for solar cells was around 2009, 2010. And not very much happened until 2012. Suddenly it's taken off. Now perovskite is starting to look as if it may challenge and exceed silicon as the material of choice for solar cells. There are some issues around stability, and it's still early, but nonetheless, pace of change. Another illustration of change, though, is here. Sequencing the genome. Human genome sequenced around the turn of the millennium. This is the cost of sequencing a genome using state-of-the-art equipment. Comes out from NIH, and you'll see it was gradually reducing, and then around 2007, 2008, something dramatic happened. Second-generation sequencers. And the cost of sequencing the genome fell dramatically. Well, that's encouraging, and we feel good about that. But if you happen to have a piece of equipment that was before 2007 and 8, it doesn't mean it costs you more to sequence the genome. It means you cannot do certain scientific research that can be done now, because the big difference was parallel sequencing, many genomes sequenced in parallel, and that opens up a completely new frontier of research if you can, at the same time, sequence 100 or 1,000 genomes rather than sequentially. So any laboratories that haven't been able to invest in capital equipment of the latest are blocked out from areas of research. So it's a message for the kind of investment that we need to keep up, I'm afraid. Pace, agility, and also sometimes patience. Another Nobel Prize awarded to John O'Keefe and to the Mosers, May-Britt and Edvard Moser from Norway, I think, yes. John O'Keefe wrote his paper in 1971, identifying so-called place cells in the brain that are relevant to location and knowing where we are, and was much criticized, and there was much cynicism about the significance of that. May-Britt and Edvard Moser visited him and spent some time in his lab much more recently, and in 2005 produced their paper on grid cells, sometimes called the GPS of the brain. So persistently continuing this line of research, producing now really very significant results, a much better understanding of aspects of the brain than we would otherwise have. So pace, agility, but sometimes patience too with science, please. And I want to quote things. Let's think about T.S. Eliot. We're talking a little bit about the bridging across from science to the arts. Where is the life we have lost in living? Yes, I ask myself that quite often. Where is the wisdom we've lost in knowledge? The knowledge we have lost in information? And we could go further. What about the information that is lost in data? So this speaks to this topic today of big data and data analytics. Again, a big change in science. Bioinformatics produces masses of data that we need to work on. You'll have heard perhaps of the fourth industrial revolution, very much, or Industry 4.0 in German terms. A big feature of this is capturing and using data in ways that we could not do had we not got the computational capability and the analytic techniques that have been developed. And the Internet of Things, putting sensors in all sorts of strange places and capturing that data is an essential part of Industry 4.0, or the fourth industrial revolution, as it's sometimes called. The differences: velocity, the pace at which things are moving; scope, to disrupt almost every industry in every country; and a systems impact, a breadth and depth that changes, really transformative way, the entire systems of production, management, and governance. And I want to speak just briefly as I come to an end to that issue. It's a systems impact, not just simple digitization, such as we had in the so-called third industrial revolution, but here forcing companies to re-examine the way they do business processes, the whole way things are done. And it emphasizes the interaction between man or people and digital technology. And in that sense, it's not enough to be an expert in one area, but to think also more widely, reaching across even to the arts and the humanities. So from STEM to STEAM. Not new. In 1851, we held the Great Exhibition in London. And actually, the commission still exists. I'm privileged to be a commissioner for this, because we're still spending the profits of that exhibition. And the objective was to increase the influence of science and the arts upon productive industry. So very visionary and very much an agenda for today. So James Dyson, well known as a UK designer of advanced engineering systems, when students learn that engineering is about making things and taking them apart, they see it's a creative subject. Engineering is a creative subject. Johnny Ives, chief designer for Apple. Design is the most immediate, the most explicit way of designing what products become in people's minds. And Johnny Ives studied design, not engineering. He graduated not from one of those leading UK universities that I mentioned, but from a middle-rank polytechnic. But a polytechnic with those strong connectivities, the benefits that come from different sorts of higher education are worth considering as well. This almost goes back to, I was in short trousers when the Lisa came out, the forerunner of the Apple, but that gave us the WIMP environment, the Windows icon, pointer type of environment. Changed the way in which we programmed, interacted with the computer. On the left, the iPod of some years ago. I remember asking my then teenage son, Edward, why is the iPod so successful? And he looked at me as if I was mad. Well, actually, he looked at me as if I was dad, which is, of course, pretty much the same thing. But what he said was, because it's cool. And that's right, isn't it? It wasn't the first, but it was the one you wanted to have. It was the nice to have. The design aspect was an important element of it, as well as the fact that it could work in a clunky sort of way. I think there's a hint, is that right? So I will stop. Oh, we can go back. Okay. We'll get there quickly. Why does it not move? Okay. So just very quickly, this actually is quite interesting for me. Studying work, how work was done, I think probably in the 1960s, late 60s, it was a thing looking at factories. My colleagues at Cranfield took a standard machine process, a lathe, and asked themselves, what would a man have to look like for this lathe to have been designed with them in mind? And this is the result. Rather long arms, rather bulky, known as Cranfield Man to some of us, and used actually in some of the courses on occupational health and safety and so on. Here's another example of design with people in mind. Helen Muir, a behavioral psychologist, studied how people behave in aeroplanes. It's followed a disaster in Manchester where an engine caught fire. They should have got out. 50 people died. She borrowed an aeroplane, got volunteers, and ran the protocol for evacuation, simulating it, and everyone got out. She did it time and again, and everyone got out. But she's a behavioral psychologist. She said, come on in again, and this time, the first 50 of you to get out will be given a £5 note in your hand. That was enough. No one got out in the prescribed time. But they were observing and videoing what would happen when people behaved thinking only of themselves, not to follow the instructions, and with relatively small changes, we are now all the beneficiaries. Things like the exit row did not used to exist. The lights along the floor did not used to exist, and some other small changes. So her subject, behavioral psychology, being brought to bear on a very, very important social challenge and really making a difference. As a scientist, what a fantastic thing to have done. This is much smaller, much less significant, but some years ago, asked to write something, I wrote about content engineering, and it was when the web was just becoming around, and I was really drawing attention that a web page that looked very good, but took ages to load and didn't work very well, wasn't very nice, but equally one that was incredibly clunky and not light to look at didn't work either because people didn't want to interact with it. And I was suggesting that we actually need people from the content world and people from the tech world to come together. And where you bring those together, you get something that Wikipedia now does indeed call content engineering. Oh yes, it may be engineering, Jim, but not engineering as we know it if you're a Star Wars fan. By people, for people. New technologies are fundamentally just tools made by people for people. They're not just. So we must keep in mind and ensure that innovation and technology continue to put people first, propelling us towards sustainable and inclusive development. So that's it. And in font design, there's an example of someone doing their master's, dyslexic, and decided to design a font that was more useful for people with dyslexia. Called dyslexia, that is it. That is, in fact, dyslexia. And it's used now quite significantly, helps a number of dyslexic people to be able to read more readily. And here's my final example, a wheelchair. You can fold a wheelchair up, but you're stuck with the wheels. Why not fold up the wheel? And that's what this does. The wheel folds up, goes so much more easily for transport and so on. And why do I mention that? Because this isn't research, is it? It is design, and it is innovation. And the Nobel Prize winner, Abid Singh Yogi, said something about research and innovation that I'm going to finish on, because I think, for me, it captures the idea really well. He said, it's about seeing what everybody has seen and thinking what nobody has thought. That surely is innovation, and it applies in so many different ways. We can make this part of culture. So I always like, as an academic, to acknowledge my sources. There you are. But jokingly, it's been said that copying from one source is plagiarism, and copying from many is research. So my talk has been widely researched. Thank you very much.